At first sight, it looks like any other star, until you glance away just for a second. You look back, but the star is nowhere to be seen, all because it's likely the fastest star out there. Now hear me out. Astronomers have recently discovered an astonishing new class of stars. They got the name hypervelocity stars. Scientists have spotted around a dozen of such stars. And it turns out that they're so speedy that they can leave our home Milky Way galaxy one day and set off on an intergalactic journey. You see, stars do weave in and out of the Milky Way galaxy's spiral arms all the time, like hurrying cars speeding through rush hour traffic. But when you look at the night sky, it may seem that these bright spots are as stationary as the monumental pyramids of Giza. Now, among those 200 to 400 billion stars that call the Milky Way their home, there is a tiny, tiny fraction that stands out. Gravitational interactions have sped those massive stars up so much that they started moving twice or even 3 times faster than our Sun. Yep, these are the very hypervelocity stars bound to break free of the gravitational embrace of our galaxy. They seem to be trying to take speeds to a new level. They move at a speed of more than 700,000 miles per hour. A hypervelocity star could zip from the moon to our planet in a mere 20 minutes. They are solitary stars, very different from previously discovered ones. The original hypervelocity stars are large and blue and seem to be born in the core of the galaxy. As for the new stars, they're quite small, not bigger than our Sun, and don't seem to come from the galactic center, which is surprising. Instead, they're often caught fleeing youthful clusters. Most hypervelocity stars are in the Milky Way galaxy's outer halo, about 150,000 light-years away from the galactic center. Interestingly, an astronomer at the Los Alamos National Laboratory in New Mexico predicted the existence of hypervelocity stars in 1988. But scientists didn't find any of them until 2005. The first star to be spotted was 350,000 light-years away from the core of the Milky Way and moved away from the center of the galaxy at about 1.5 million miles per hour. Astronomers say that it's extremely difficult to kick a star out of the galaxy. One of the most common mechanisms for doing so is some kind of interaction with a supermassive black hole at the galactic core. So, Sagittarius A, which might be the very black hole we're looking for, at the center of the Milky Way, probably accelerates hypervelocity stars, or at least some of them. To reach escape velocity, a star must get a more than 1 million mile per hour kick. But since the Milky Way's central black hole has a mass of 4 million suns, it has enough power to produce something like that. The most typical scenario involves a binary pair of stars. This is a system of 2 stars that are gravitationally bound to and in orbit around each other. So, let's say these stars get caught in the grip of our black hole, and as one of the stars is spiraling inward towards the black hole, its sibling is flung outward at a tremendous speed. This is called a 3-body exchange. Astronomers have already found 18 giant hypervelocity stars that could have been produced by this mechanism. There's also a theory that hypervelocity stars might be ejected from dense stellar clusters by supernova explosions. The newly discovered hypervelocity stars seem to have the same composition as regular stars. That's why astronomers don't think that their birthplace could be some exotic place outside the galaxy or in the outer halo of the Milky Way. The thing is, it's a lifeless region full of old, metal-poor, and low-mass stars, and it's impossible to see a hypervelocity star there, unless it was ejected in that direction. So, hypervelocity stars still remain a mystery for us, but they're not the only stars out there that act weird. For example, in 2017, astronomers spotted a bright star hurtling out of the Milky Way. It was moving incredibly fast at a speed of 2 million miles per hour, which is almost 4 times as fast as the Sun orbits around the center of the Milky Way galaxy. Anyway, The main issue with the wandering star was that it was moving against the direction in which most stars travel around the center of our galaxy. And it wasn't the only bizarre thing about it. Its appearance evoked a lot of questions. Was it a hypervelocity star? Was it even a star? The space traveler consisted of totally different star stuff. Astronomers managed to identify its composition. It was made up of heavy metallic atoms. Most other stars consist of way lighter elements. The wandering star got its name LP40-365. It was moving so fast that it literally dashed out of our galaxy. This made scientists believe that it was pushed out of its place by some kind of cosmic disaster, like a supernova. These days, astronomers claim that the star, which was previously considered to be a white dwarf, is actually a piece of star shrapnel. Kind of a leftover after a more massive star experienced a supernova. The explosion must have been so powerful that it pushed LP40-365 into interstellar space. This piece of a previously glorious star keeps slowly rotating around its axis. This is more proof astronomers need to claim LP40-365 is indeed just a chunk of space debris and not a full-fledged star. But such a conclusion means that it has witnessed a supernova. Even though this event happened lightning fast, the entire makeup of this space object was changed. You see, most stars consist mainly of helium and hydrogen, but LP40-365 is different. It contains such heavy elements as magnesium, oxygen, and neon. It must have been the supernova that added these atoms to the star's composition. By the way, astronomers considered all elements that are heavier than helium to be metals. This means that after witnessing the supernova, LP40-365 became metallic. Our space traveler brightens and then dims again every 8.9 hours. It might mean that the star pulsates, but usually stellar pulsations are much less regular. A more plausible explanation is that the star's surface is uneven, and as it spins, sunspots are brought into and out of view. Let's move to another unusual space body. It's the 18th brightest star in the night sky, and it's called Fomalhaut. If you look at it through a telescope, you'll be met by a terrifying sight. No wonder it's dubbed the Eye of Sauron. A ring of dust and debris circles it, making it look like a giant eye staring straight into your soul. The intimidating star is more than twice the mass of our Sun and is 25 light-years away from Earth, which isn't that far away considering distances in space. Then there's a star that is tearing itself apart. It has a beautiful name, Vega. At first sight, it seems to be normal, large, bright, and pretty young. But the deeper you go, the weirder it gets. For example, it's not actually round. It looks like an egg. It might be because the star rotates so fast that its shape gets distorted, causing temperature variations across Vega's surface. It's also going 93% of the maximum velocity a star this big can handle. And I mean a mind-boggling 170 miles per second. Astronomers aren't sure why Vega is rotating so fast that it's almost tearing itself apart. Mira is sometimes one of the faintest and sometimes one of the brightest stars in the night sky. This system actually consists of two stars. One of them is a red giant that once resembled our Sun. The other is a white dwarf. The red giant is constantly shredding its outer layers, creating clouds of debris around the whole system. This phenomenon might be the reason for the regular dimming of the stars. It can also explain why the intervals between these periods of dimming aren't regular. But the coolest thing? It gives the stars a comet-like tail.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.